Hi students, welcome to exercise 36, oblique asymptotes and solving rational equations graphically and algebraically. Alright, so let's first solve this rational equation algebraically. So here basically just using some algebra to solve for x. Okay, so the first thing I'm going to do is I'm going to bring this 1 over to the other side. So you'd have 1 over x plus 2 equals to 4. And then to solve for x, I need to bring x to the numerator. So what I'm going to do is I'm going to multiply each side by x plus 2. What that's going to do is it's going to relieve it from the denominator, right? It's going to eliminate it. And you have 4 times x plus 2. And then you multiply through, and then we solve for x. So bring the 8 over there, and you divide. Okay, so step by step to solve for x here. Now, how would you solve that graphically? Well, you've got some options. I usually like, especially for you guys, graphically, to just take each part of the equation, right? So my first equation would be 1 over x plus 2 minus 1, and y2 would be equals to 3. Alright, so graphically, so this is basically just sketching this graph. Notice this is the graph of 1 over x, moved 2 to the left, 1 down. Okay, so 2 to the left, 1 down, which means your vertical asymptote will be x equals negative 2, right, because that's your divide by 0. And then your horizontal asymptote is going to go down 1. Okay? Those should be dotted lines here. Alright, and then now the graph, since there's no stretch or compressions or reflections, you're going to have a point at 1, 1 from this vertex here, and when 1, 1 in the opposite direction. Okay. Again, if you're not sure, all you got to do is put a table of values, right? And then you plug in one value from each side of your vertical asymptote. So negative 1 and negative 3. Okay, and then you plug those in. You plug in negative 1, you're going to get 1 over 1 minus 1 is 0. And then you plug in negative 3, you're going to get negative 2. So again, you just plug them into your formula. Alright, so our graph will do something like this. See if we can sketch that properly. Alright. I'm going to keep going here. And got that. So this is y1. And now the graph y equals 3 is just the horizontal line here, right? And we cross at this point. So that is the point that we found algebraically, negative 7 over 4, which is negative 1.75, which does correspond pretty well to our graph. Alright? Alright, so next example, we have 2 over x minus 1 and x minus 2. Alright, so algebraically, same idea. I'm just going to rewrite the original equation here. Okay, so again, we want to take away that x minus 1 from the denominator, bring it to the numerator. So the way you're going to do that is you're going to multiply both sides by x minus 1. Okay, and that's going to cancel out this x minus 1 here. You have 2 equals 2, and then I'm going to expand this. So this is a trinomial. So minus 2x minus x, which is minus 3x plus 2. Okay, so then I got to solve this. So I need equals 0 for one side. So bring the 2 over. So subtract 2 on both sides. And now, this is no longer trinomial, but there is a common factor between x squared and 3x, and the common factor is x. So what we're left with is x times x minus 3. So there are two solutions to this problem. There's x equals 0, and there's x equals to 3. Alright, so algebraically, pretty easy. Now graphically, again, I'm going to sketch it. I'm going to use the equations exactly as written. So I'm going to sketch 2 over x minus 1. I'll change colors for you guys this time. And we have y equals to x minus 2. Okay, so let's sketch these. So first of all, let's sketch our 2 over x minus 1. Notice that divided by 0 at x equals 1. Therefore, that's where our asymptote's going to be. Right? X equals 1 is our asymptote. Sorry, I'm off the line a bit here. Okay, and then here, because we do not have any vertical translation, the horizontal asymptote will be at 0. Okay, there is a stretch by 2, so that means on either side you're going to go 2 up and 2 down, right? So 2 up and 2 down. Perfect. Okay, so what we have here is just the rational graph. If you want to make more points, because we do have 2 points here, notice that algebraically gave us a hint that we'd have x equals 0, so we should pass by this point, and x equals 3. So you probably want to find a point at x equals 3 if you're not sure how to do that. Okay, so at x equals 3, this graph, you have 2 divided by 3 minus 1, so 2 divided by 2 is 1. So at x equals 3, y equals 1. And since the points are corresponding on both sides, so you have 2, 1, you're going to have 2, negative 1 on this side. Might as well add this point over here. So our graph does something like this. So again, this is our y1 graph. Okay, so this is y1. It's in red. Now, the blue graph is just the linear function x minus 2. So x minus 2 passes by here and has a slope of 1 over 1, right? Because that's the slope of x. So 1 over 1 moves up 1 over 1, up 1 over 1, right? So you go up 1 over 1, up 1 over 1, up 1 over 1, and that's where that point is shared. Okay, and then these are all your points. So this is your function. And therefore our 2 solutions were x equals 0 and x equals 3, which match what we did algebraically. Alright, so oblique asymptotes. An oblique asymptote is basically a diagonal asymptote. So instead of having a vertical asymptote or horizontal asymptote, you're going to have an asymptote that goes kind of across the graph. Okay, so this will only happen when the degree of the numerator is larger than the denominator, when the denominator is not a factor of the numerator. Okay, so that's maybe important, so you have to be able to recognize that, so it's an oblique asymptote. So again, repeat, the degree of the numerator, so here the degree of the numerator is 2, right, is larger than the denominator, degree of the denominator is 1, so that's true, and when the denominator is not a factor of the numerator. So here, is x plus 1 a factor of this? It isn't. The reason is I know that is because I cannot factor that numerator. This is unfactorable. Therefore, x plus 1 is not a factor. Alright, the way we're going to sketch these, we're going to complete the division. So we're going to do the synthetic division that you guys know fairly well at this point. So you have negative 1, which is the 0, right, of your denominator, so negative 1. And then you have your coefficients, so 1, negative 1, negative 1. Okay, so you're going to bring down that first number, that's 1. You multiply these two, you get negative 1. So negative 2 now, multiply again, you get 2, and the remainder is 1. Alright, so if I was to rewrite this equation, I would get y equals 2, x minus 2, right? So that's the coefficient of x, because you divided x squared by x, you get x. Minus 2 plus 1, and that plus 1 is still divided by x plus 1. Alright, so the quotient is the diagonal asymptote, and then you have this remainder, which is basically your rational function. Okay, so your quotient, this is the diagonal asymptote right here. Okay, that's not a nice bracket here. Let's try that again. Kind of okay. Alright, so x minus 2 is your diagonal asymptote. So in this case, the diagonal asymptote would be y equals to x minus 2. Okay, so this is the linear diagonal asymptote, and then kind of the rational graph. So notice that there's a non-permissible value here. X cannot equal to negative 1. Alright, so let's put this on a graph as best as we can. So y equals to x minus 2, let's put this on the graph. So this is just a linear function across here. So again, this is an asymptote, so I'm going to put that as a just this point here as a dotted line. Try to do my best to stay in the right spots. There we go. So this is y equals to x minus 2. Alright, and we also have a vertical asymptote at x equals negative 1 because you're dividing by 1. So, okay, so can keep going down. Do my best to draw this. Okay, not always easy to draw. Alright, so this is your vertical asymptote at x equals 1, and you have a diagonal asymptote at y equals x minus 2. Alright, so next thing you need to do, you basically need to find some points, and then kind of connect the dots. Alright, so I'm going to do what I do normally. So you have y, x, y. I'm going to find a point on either side of this vertical asymptote. So I'm going to choose -2, and I'm going to choose x equals 0. So -2 and 0. And then all you got to do is plug them into your function. You can plug them into here. You can plug them into your original. That's up to you. But plug them into one or the other. Alright? So I'm going to plug them into the divided version because I can see that with my table of values. Okay, so if I plug in -2, I'm going to get -2, -2, which is -4. -4 plus 1 over -2 plus 1, which is -1. So -4 minus 1 is -5. So I have a point at -2, -5. So that would be our point right here. Okay, so since the graph goes on, I'm going to extend this asymptote a little bit. Alright, so I'm going to do the same thing for x equals 0. So I'm going to plug it in here. So 0 minus 2 is -2. 1 over 1, which is 1, minus 2 plus 1 is -1. So we have a point at -1, so we have this point here. Notice that, just like before, this point, so we go up 2 over 1, here we go down 2, left 1. So it's still the exact same properties as we used to have for rational graphs. And now the graph goes towards the asymptote. Well, this is where the graph looks a little bit different. So we're going to go towards the asymptote over here, okay? And I'm going to curve, and I kind of missed that curve. Hopefully I can do a bit better job here. And we're going to do something like that. Okay, I'm going to try that again just to try to give you guys a better idea of what it looks like. Okay, so you're going to curve down here and towards the asymptote. And that's what the graph's going to look like. Okay, a little bit funky, but again, fairly easy to do in terms of process. Alright, last example. Let's sketch this graph. So we have y equals 2. I'm going to put it in order here. So -x squared plus 2x plus 3 over x minus 2. So again, the first thing you should do is you should check whether you can get rid of this factor. Because if this is a factor of the numerator, it is not an oblique asymptote. Okay, so I'm going to factor the negative, just to get something that I can work with, factor a little bit better, I should say. So you have x minus 2. So you factor the numerator to x minus 3, x plus 1 divided by x minus 2. Alright, so notice it's pretty clear that x minus 2 is not a factor of your numerator, and the numerator has a larger degree than the denominator. You can tell that here, 2 factors and 1. So this is a case where there's an oblique asymptote. So what you guys are going to do is you're going to complete the synthetic division. So the synthetic division will work from there. So I'm going to move that guy down, because I'm going to take the coefficients of the trinomial, and I'm going to take the 0 of your denominator. So 2 is the 0, and the coefficients are -1, 2, and 3. Okay, you bring down the first one, you get -1. 2 times -1 is -2. You get 0 here. 2 times 0 is 0. You get a remainder of 3. Okay, so what this does, okay, was we're going to write the equation here. Y equals to -x. This is -x plus 0, and then plus 3 divided by x minus 2. So that's your remainder. It's still divided by x minus 2. Okay, so just to make sure, note, therefore, y equals to -x. So this part right here is the oblique asymptote. Okay, so what we're going to do is sketch that oblique asymptote, y equals -x. So this is basically just the line that comes diagonally across our screen right through the origin. Okay, so this is your oblique asymptote, -x. We also have a vertical asymptote at x equals 2, because you divide by 0 there. So you have this over here. Okay, so again, all I'm going to do is I'm going to find a point on either side. So I'm going to just put a little table of values right here. Hopefully it doesn't get in the way. So I'm going to choose one from either side, and you can even choose x equals 0. That's never a bad one to take as well, right? So maybe I'll choose x equals 0, x equals 1, and I'll choose x equals 3, which is on the other side of that asymptote. Alright, so if I plug in x equals 0, you get 0 plus 3 over negative 2, so negative 3 halves. If you choose x equals 1, you get negative 1 over negative 3, so negative 4 over here. And at x equals 3, you get negative 3 plus 3 over 1, so negative 3 plus 3 is 0. So again, these points should correspond on both sides, okay, according to this origin from where they cross. Okay, so let's plug those points. 0, negative 3 halves, so 0, negative 1.5. Then this is 1, negative 4 over here. And you have 3, 0 over here. So again, this point corresponds. You got 1 over, 2 up, 1 left, 2 down. Okay, and you can even add another point if you would like. You go 2 over half up, 2 over half down. So you'd have this point. And you can verify that by plugging in x equals 4 into this table of values. Alright, so this graph is going to look something like this. Again, you're going towards the asymptote, so again, a little bit different looking graph. So our graph's going to look like that. It's going to go towards the asymptote. And same thing over here. You're going to have a graph that looks like that. Alright, so again, pretty funky graph, eh? And solve the equation. So if I wanted to solve the equation, 3 over x minus 2 minus x equals 2x minus 6. This is just solving algebraically, right? So what I'm going to do is I'm going to move this x over, and notice this is our graph over here, right? Okay, so it's the exact same graph. I'm just solving it when it's equal to 2x minus 6, which is a line that comes across like that. Okay, so I'm going to move this x over first. So you're going to have 3 over x minus 2 equals to 3x minus 6. Okay, so I'm going to multiply x minus 2 on both sides here. So you have 3 equals to 3x minus 6 times x minus 2. Expand that out, so you have 3x squared minus 6x minus 6x plus 12. 0 equals to 3x squared minus 12x minus 3, so plus 9. Notice that I can divide everything by 3, makes my life a little easier. Because we have a common factor of 3, and I can factor that, x minus 3, x minus 1, and we have x equals 3 and x equals 1. Alright, the way that corresponds to the graph, because this is our graph, negative x, 3 over x minus 2, same thing here. When is it equal to 2x minus 6? Well, 2x minus 6, I'm just going to put the line on the graph here. 2x minus 6 is just this. I'm going to sketch a dotted line because I didn't ask you to sketch it. Okay, so this would be the 2 points where it crosses. So graphically, all I'd have to do is sketch this line and show that it crosses those 2 points. Algebraically, well, that's the way we would do it algebraically. Alright guys, I hope that made sense. Oblique asymptotes is not a big part of this course, but part of this course nonetheless. Alright, good luck.